Welcome back everyone. So in this video, we will be covering the theorem on radian measurement. Okay. So the statement of the theorem is the radian the radian so defined is independent of the radius of the circle used, and we also need to prove that pi radian is equal to 180 degree. So whenever we start with a theorem or a proof, we have few assumptions. So let's state the assumptions made in this particular theorem. So the assumption is let there be a circle with center O and radius OA and OB is equal to R. Okay. Let the length of the arc AB be equal to the radius of the circle, which is equal to R. Okay. Extend OA to the opposite side till point C such that angle AOC is equal to 180 degree or a straight angle So one more thing I would like you guys to know is that one straight angle comprises of two right angles. So one straight angle comprises of two right angles. That means in numerical terms we can write 180 degree as 2 into 90 degrees. Okay, so these are the assumptions we have made, and according to this assumption there's a diagram given besides. Okay, so if radius OB, radius OA is equal to R, and also we have assumed that length of arc AB is also equal to R, that automatically the angle subtended by definition of radian measurement will be how much? That is, angle AOB will turn out to be 1 radian. Okay, so these are the informations we have right now. This is the information we have right now, and based on this information we will be solving the theorem. So this is the assumption part. Note it down, and we will start with the main part of the theorem now. Okay, so in the proof part, if you remember, length of the arc is given by S is equal to R theta. This was the formula. This is the formula we will be using. Length of the arc is directly proportional to measure of the angle. Okay, so the bigger the length of the arc, the more will be the angle subtended at the center. So can I say, for example, arc AB upon arc ABC, I can take ratios of two arcs, and similarly on the right hand side of the equal to part, I'll take ratios of their subtended angles as well. So that will be measure angle AOB is equal to measure angle AOC. Okay, so this is what we get. Now arc AB is equal to R. We got this from the given assumption. Okay, So we have something to substitute for arc AB. Now similarly, we need to find something to substitute in place of our ABC. Arc ABC is actually half of the entire circumference of the circle. So that will be half of 2 pi r, half of 2 pi r. 2 and 2 get cancelled, you are left with pi r. So this is substitution for arc ABC. So now we will substitute both in the given equation. So erasing the upper part, I hope you have noted it down. Okay, so continuing, r upon pi r is equal to measure angle AOB upon measure angle AOC. Okay, so r and r get cancelled. So we are left with 1 upon pi and measure angle AOC. So solving this further, I'm erasing the part below now. I hope you guys have noted it down. The way I write, the moment I write on the screen, it's expected that you note down this in your notebooks. Okay, so the next step, what we can do is, we can write measure angle AOB is equal to 1 by pi times measure angle AOC. Okay, now measure angle AOC, as we discussed earlier, it is equal to 180 degree. So in place of measure angle AOC, we put 180 degree. Therefore, we get measure angle AOB, which is actually equal to 1 radian, as per the definition of radian measurement, is equal to 180 degree divided by pi. And this proves, and this particular statement proves both of our requirements. First requirement, radian so defined. So this is the radian so defined. 1 radian is given over here in the boxed part, is independent of the radius. Yes, it is independent of the radius. It depends only on 180 degree and pi. It's a constant, okay, of the circle used, and pi radian should be equal to 180 degree. It's now easy to prove that pi radian is equal to 180 degree. We will cross multiply pi. So pi radian is equal to 180 degree. We get. This is the second proof. So both the parts have been proved. You can say hence proved. And this is where our theorem ends. So I hope you understood the proof part and assumptions part which we made to solve this theorem, to prove this theorem. Okay. So in the next lecture, we will be starting with numericals of exercise 1.1 from your standard 11th Arts and Science Mathematics 1 textbook. So make sure you also have your textbook open while you attend the next lecture. Also note down the solutions which I'll be giving you. I'll be solving each and every sum of exercise 1.1. So don't miss out on the next lecture. Meet you in the next lecture. Thank you so much.